हेलो दोस्तों, वेलकम टू आवर चैनल साइनिंग ब्रेन। आज हम एनसीईआरटी क्लास 7 का चैप्टर नंबर 5 पढ़ने जा रहे हैं। चैप्टर का नाम है एसिड्स, बेसेस एंड साल्ट्स। नाउ लेट्स स्टार्ट। We use in our daily life a large number of substances such as lemon, tamarind, common salt, sugar, and vinegar. Do they have the same taste? Let us recall tastes of some edible substance listed in table 5.1. If you have not tasted any of this substance, taste it now and enter the result in table 5.1. Caution: do not taste anything unless asked to do so. Do not touch anything unless asked to do so. You find that some of these substances taste sour, some taste bitter, some taste sweet, and some taste salty. 5.1 Acids and bases. Curd, lemon juice, orange juice, and vinegar taste sour. These substances taste sour because they contain acids. The chemical nature of such substances is acidic. The word acid comes from the Latin word acre, which means sour. The acid in these substances are natural acids. What about baking soda? Does it also taste sour? If not, what is its taste? Since it does not taste sour, it means that it has no acid in it. It is bitter in taste. If you rub its solution between fingers, it feels soapy. Generally, substances like this, which are bitter in taste and feel soapy on touching, are known as bases. The nature of these substances is said to be basic. If we cannot test every substance, how do we find its nature? A special type of substance are used to test whether a substance is acidic or basic. These substances are known as indicators. The indicators changes their color when added to a solution containing an acidic or a basic substance. Turmeric, litmus, China rose petals, gudhal, etc. are some of the naturally occurring indicators. Do you know name of acid found in acetic acid found in vinegar, formic acid found in ants sting, citric acid found in citrus fruits such as orange, lemon, etc. Lactic acid found in curd, oxalic acid फाउंड इन स्पाइनेच, स्कॉर्बिक एसिड इसको विटामिन सी भी बोलते हैं, आंवला, साइट्रस फ्रूट, tartaric acid, tamarind, grapes, unripe mangoes, etc. All the acid mentions above occur in nature. Name of bases: calcium hydroxide found in lime water, ammonium hydroxide found in window cleaner, sodium hydroxide या potassium hydroxide found in soap, magnesium hydroxide found in milk of magnesia. Can I taste all substances to find their taste? No. Have you not read the caution? We should not taste unknown substances. They could harm us. 5.2 Natural indicator around us. Litmus, a natural dye. The most commonly used natural indicator is litmus. It is extracted from lichens. It has a mauve purple color in distilled water. When added to an acidic solution, it turns red, and when added to the basic solution, it turns blue. It is available in the form of solution or in the form of a strip of paper known as litmus paper. Generally, it is available as red or blue litmus paper. Activity 5.1 Mix some water with lemon juice in a plastic cup, tumbler, test tube. Put a drop of the above solution on a strip of the red litmus paper with the help of a dropper. Is there any change in color? Repeat the same exercise with the blue litmus paper. Note down if there is any change in the color. Perform the same activity with the following substances: tap water, detergent solution, aerated drink, soap solution, shampoo, common salt solution, sugar solution, vinegar, baking soda solution, milk of magnesia, washing soda solution, lime water. If possible, mix solution in distilled water. Record your observation as in table 5.2. In your table, are there any substances on which litmus had no effect? Name those substances. The solution which do not changes the color of either red or blue litmus are known as neutral solution. These substances are neither acidic nor basic. Turmeric is another natural indicator. Activity 5.2. Take a tablespoonful of turmeric powder, add a little water, and make a paste. Make turmeric paper by depositing turmeric paste on blotting paper, filter paper, and drying it. Cut thin strip of the yellow paper obtained. Put a drop of soap solution on the strip of turmeric paper. What do you observe? To prepare lime water, take some water in a tumbler and add some lime chuna into it. Stir the solution and keep it for some time. Pour a little from the top. This is a lime water. You can prepare a greeting card from your mother on her birthday. Apply turmeric paste on a sheet of plain white paper and dry it. Draw a beautiful flower and with soap solution with the help of a cotton bud. You will get a beautiful greeting card. Similarly, test the solution listed in table 5.3 and note down your observation. You may try solution of other substances also. China rose as indicator. Collect some China rose, good hull, petals and place them in a beaker. Add some warm water. Keep the mixture for some time till water become colored. Use the colored water as an indicator. Add 5 drop of indicator to each of the solution given in table 5.4. What is the effect of the indicator on acidic, basic and neutral solution? China rose indicator 5 figure 5.3 turns acidic solution to dark pink magenta and basic solution to green. This is the figure 5.3 China rose flower and indicator prepared from it. Activity 5.4. The teacher is requested to get the dilute solution of the following chemicals from his or her school laboratory or from a nearby school: hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, ammonium hydroxide, calcium hydroxide, lime water. Demonstrate the effect of the three indicators on each of these solutions. Record your observation in table 5.5. Here one information is given. Are you familiar with the term acid rain? Have you ever heard about damaging effects of acid rain? As the name indicates, the acid containing excess of acid is called an acid rain. Where do these acids come from? The rain become acidic because carbon dioxide, sulfur dioxide and nitrogen dioxide, which are released into the air as pollutant, dissolve in raindrops to form carbonic acid, sulfuric acid and nitric acid respectively. Acid rain can cause damage to buildings, historical monuments, plants and animals. Caution: great care should be taken while handling laboratory acids and bases because these are corrosive in nature, irritating, and harmful to skin. 5.3 Neutralization. We have learned that acid turns blue litmus red and bases turns red litmus blue. Let us see what happens when an acid is mixed with bases. We are going to use an indicator you have not used so far. It is called phenolphthalein. Activity 5.5. To be demonstrated by the teacher in the class, fill 1/4 of a test tube with dilute HCl. Note down its color. Note down the color of phenolphthalein solution also. Add 2 to 3 drops of indicator to the acid. Now shake the tube gently. Do you observe any change in color of the acid? Add to the acidic solution of a drop of a hydrochloric acid, sodium hydroxide solution by a dropper. Stir the tube gently. Is there any change in the color of the solution? Continue adding the solution hydroxides sodium hydroxide solution drop by drop while stirring till the pink color just appears. Now add some more drop of dilute hydrochloric acid. What do you observe? The solution again become colorless. Again add 1 drop of sodium hydroxide. Is there any change of color? The solution again become pink in color. It is evident that when the solution is basic, phenolphthalein give a pink color. On the other hand, when the solution is acidic, it becomes colorless. Here figure 5 shows the process of neutralization, the mixture of acid plus indicator with bases. When an acidic solution is mixed with a basic solution, both the solution neutralize the effect of each other. When an acid solution and a base solution are mixed in suitable amount, both the acidic nature of the acid and the basic nature of the bases are destroyed. The resulting solution is neither acidic nor basic. Touch the test tube immediately after neutralization. What do you observe? Is neutralization reaction heat is always produced or evolved? The evolved heat raises the temperature of the reaction mixture. In neutralization reaction, a new substance is formed. This is called salt. Salt may be acidic, basic, or neutral in nature. Thus neutralization can be defined as follows. The reaction between an acid and a base is known as neutralization. Salt and water are produced in this process with the evolution of heat. Acid plus base arrow, salt plus water. Heat is evolved. The following reaction is an example. Hydrochloric acid HCl plus sodium hydroxide NaOH gives sodium chloride NaCl plus water H2O. Bozo added dilute sulfuric acid to lime water. Will the reaction mixture become hot or cool? 5.4 Neutralization in everyday life. Indigestion. Our stomach contain hydrochloric acid. It helps us to digest food as you have learnt in chapter 2. But too much of acid in the stomach causes indigestion. Sometimes indigestion is painful. To relieve indigestion, we take an antacid such as milk of magnesia, which contain magnesium hydroxide. It neutralizes the effect of excessive acid. Ant bite. When an ant bites, it injects the acidic liquid formic acid into the skin. The effect of the acid can be neutralized by the rubbing moist baking soda, sodium hydrogen carbonate, or calamine solution, which contain zinc carbonate. Soil treatment. Excessive use of chemical fertilizer makes the soil acidic. Please do not grow when the soil is either too acidic or too basic. When the soil is too acidic, it is treated with bases like quicklime, calcium oxide, or slick lime, calcium hydroxide. Is if the soil is basic, organic matter compost is added to it. Organic matter released acid which neutralizes the basic nature of the soil. Factory wastes. The wastage of many factories contain acid. If they are allowed to flow into the water bodies, the acid will kill fish and other animals. The factory wastes are therefore neutralized by acidic basic substances. This is the end of the chapter number 5. Here some keywords are given: acid, basic, neutralization, acidic, indicator, salt, base and neutral. So मिलते हैं अगले चैप्टर नंबर 6 में, तब तक के लिए थैंक यू।